Greetings, fellow folks. Welcome to another episode of ML for Noobs. And today's going to be a really interesting episode. We're going to be picking up from where we left off. So, last episode, we did say that we're going to attempt a second application of all the stuff that we've been learning over the course of the first two lessons of Fast AI. Right? Now, namely, there's a second application. The second application that we're going to be working on is a CAPTCHA solver. So I have an example of a website here, cglat.bh, and they have a sample CAPTCHA that we are going to attempt to solve. Now, you can obviously tell right off the bat that there is a bit of interference, some background, and so this is going to make our life a little bit more difficult. I say a little bit because there's ways to fix this up. And so what I want to do is I want to be able to apply all the stuff that we learned to plus many things that we didn't actually learn. So you can imagine there's a lot of stuff going on with separating the different digits, getting rid of the background, figuring out how to do inference, how to get rid of the various backgrounds, and all these cool things. So we'd like to be able to learn how we can actually solve this CAPTCHA as a practical exercise. So it's a lot of the stuff. So some of the stuff that we've actually learned, plus a lot of stuff that we actually haven't, but that would be super useful when we do attempt to solve our own problems. All right, so that's the second application that we're working on. Third, we're going to be picking up on the other application that we started working on. So remember, we started trying to figure out how we can categorize various lines, right? There's Ryan Reynolds and there's Ryan Gosling. And they look pretty similar. It's very hard to tell the difference. And so we seek the assistance of machine learning in order to definitively categorize an image as either being Mr. Reynolds or Mr. Gosling. And so that's an exercise that we've previously tried and had mild success on. I'm not going to say we failed, but we had mild success. And there were several cases where it incorrectly categorized, I think it was Mr. Gosling as being Reynolds. And so we'd like to get to the bottom of that, figure out why it's not working, what we need to do in order to fix it. So that's going to be a more advanced exercise. It's not going to benefit a whole lot. Maybe it's going to benefit a little bit from the ImageNet data set that we have because it has a bunch of images about people. However, I don't know, to what extent it'd be able to help, at least in terms of defining various characteristics of specific individuals. But anyway, that's not an exercise we're going to be worrying about just yet. Our focus right now is on this little exercise here. Now, I do have a blog post that's going to help out a little bit. It's going to serve as our reference because I'm still pretty new to Python, and so there's a lot of stuff that I will admit that I do not know. And so, we'd be able to seek some assistance and some help from our friend here, Mr. What's his name? Mr. Adam Gategay. Mr. Adam Gategay here, 15 minutes to break a CAPTCHA. I love that. This is definitely a challenging exercise. And he's using this library called OpenCV in order to do the character segregation here. A bunch of CAPTCHA characters here, and he essentially used this library in order to do the segregation, which is definitely something that we want to implement in our case because we have a very similar challenge here. Now, I will say that when you try to reload this page, so let's go ahead and see what happens when we reload this page. Just want to understand a little bit more about the environment that we're in and what we're trying to achieve here. So when you hit search CR, which is the page that we're actually interested in, you can see that the image changes naturally, and the type of background changes. I don't know if the position of these characters is changing or not. It seems to me like they have a fixed position, and maybe that's something that we can actually take advantage of. I don't know, but yeah, that's something to consider. Also, one more thing is that the image changes. So every time I do a refresh, the image itself changes, and you can see this is actually a PNG image. So if I were to, let's see, how would we do this? So if I were to go to project Fast AI, and here let's do CAPTCHA solver. All All right, so if I were to do, let's just create an HTML file, and I'm just gonna do image. Whoa, what happened there? Yep. All right. Okay, I don't know what that is. Alright, touch index.html. Let's just say if I were to try and create a simple index.html file here, and all we're trying to do is we want to display the image. So let's go ahead and do that. We're going to go to CAPTCHA solver here, and we have an index.html, and we're going to create an image src, and we're just going to paste. Alright, we're not going to paste that. What we are going to paste is this URL up here. So let's go ahead and put that, and then just save it and open up our index.html. So let's go ahead and do that. Okay. All right, hello. Let's open that up. There we go. Oops. Wrong tab. So let's open it up here. All right, there we go. That's our image. That is our image. And if I were to repeat this, say, 10, 15 times, you would get the same image. But you know, we don't want the same image. We want to change the image a little bit each time. And so what I'm going to do is I'm just going to add a bit of a modifier to the image. And so, you know, if I were to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. It's not actually going to change the image, but what would it do? Okay, this is interesting. This is very interesting. Notice how the numbers are not changing. It's showing me the same number. It's changing the image, which I find very interesting. This is a very interesting. Gotcha. This is very, very interesting. It's fascinating. Huh. Well, a few things off the bat. I know it looks like the position is not changing. The position across these images is not changing. And so I'm thinking, you know, if I were to actually set up a bunch of steps that I would want to follow, I'd say step 1, download a bunch of images. And the way we would do that is we would actually say, all right, download, since it's retrieving the same images with different kind of transforms, essentially they're doing different transforms here, right? And so what we would do is we would download, so create, you know, obviously what's happening here is that it's got a session, so it's keeping track of what the number is per session, and it's generating, you know, an image with a different transform each time. And so when you create a new session, that's when you're going to have a different number. And to prove this, if I were to open a new incognito page and I were to go to that same file, interesting. It's showing you nothing. I presume it's because you have to hit the website first. This is a weird arrangement, all right? This is not how it normally works. But this just makes it even more interesting, right? So I have to hit the search CR page, presumably, 9700, and now when I open it up, I'll get 9700 and all sorts of different, you know, forms. All right, that's cool. That's fine. And it's keeping track of that, so even if I refresh, it's not going to change how this one looks, right? So it's based on a session. That's almost certainly the case. And so start new session. The way this would work is start new session, and then download X variants. Let's say 50 variants of the CAPTCHA code. All right, 50 variants. That's nice. And then what you're going to do is delete dupes, right? Delete the duplicate ones because you have a bunch of you just did a simple refresh and you already have a couple of duplicates here, right? So you just want to get rid of all of the dupes, all right? So delete the dupes and then iterate, right? And then repeat, say 100 times. So what you're going to do is, this means that you can actually get, potentially 50 times 100 is 5,000 training images. Very nice. 5,000 training images, very nice. By only labeling it 100 times. Is that insane or what? This is awesome. All right. So that's how it's going to work. And then we would segregate the characters. And the way that you would segregate the characters is using OpenCV. That's what the guy was suggesting over there. You would just use something like OpenCV in order to get this job done, right? Oh, this is very different. This is very, wait, is this a different? This is a different guy. This is very different. This is very interesting. All right, this is very interesting. Solving CAPTCHAs with Deep Learning Part 2 Single Character Classification. And here he has much more complicated characters. This is not something that we considered before. Like this guy, what's his face? Adam, Mr. Adam Gay. He had images that were fairly separate. All right. Now, for the case where you have some mixed images, he gives an example here. For the case where you have some mixed images, he splits the image in half. All right, it's very simple. It's very simple. But this bad boy here, Mr. Who's this guy? Mr. Oliver Mueller. Mr. Oliver Mueller is taking on a much more difficult challenge. You can see there's interference from the background. I don't know if this is going to be a problem for us or not. So before you segregate characters, you also need to consider, so the second step, this is actually going to be the third step. The second step was based on what this guy did, Mr. Adam. He did, what does he call this? Yeah, convert the image into pure black and white. So do thresholding. So do thresholding, convert image to pure black and white. And then I don't know, do we need to do this? Get rid of the background somehow. Get rid of the background. I don't know if this is something that we need to do. Get rid of the background. Maybe something we need to do. And then after that, you would actually work on segregating our characters. And then what would you do next? Alright, blah, 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 and then build and train the neural net. Alright, so at that point, you just do train. Alright, this is the stuff that we already know. The training part, simple. We're not going to have any issues there. Right? The challenge is just going to be all the stuff that, so this is the stuff that we actually learned. This is all new stuff, right? And so that's going to be very interesting. It's just learning this stuff around what we need to do. And I think this might actually be useful when we attack that third exercise, the more complicated exercise. But anyway, this is enough of a starting point for us. Let's. I want to take, before we dive into actual code. What I'm going to do is I want to actually read what Mr. Oliver Mueller did over there, just to understand how he fixes it. All right. And so overview of our approach. All right, that's what this is right here. These are the steps that we're going to follow in order to get this deed done. All right. Now I want to take a look at this one more time and see, just take a guess as to how Mr. Oliver would approach this. And you can see, all right, there's definitely interference from the background. Like you got that squiggly line all over the place. That kind of messes up this approach that Mr. Adam is taking here. Right? It's not going to work. It's not going to work if you're going to do this, because that line is just going to be everywhere and you're going to have a big blob. All right, you're not going to have segregated regions like this. You're just going to have a big blob. So how do you get around that? That is a good question. That is a good question. I don't know. I know what the answer is. My thoughts would be, how would you figure out what the characters, how would you segregate the characters from the background? Well, my thinking would be, all right, what if what they do is they try to find certain density of pixels. Like you can notice that the line is always a certain thickness, right? And it's very thin relative to the actual characters. and it's mostly horizontal as well. That's a certain property of the line that you can make out. So there's probably two approaches to doing this that I can think of. I'm sure there's many more out there. But one is you train a neural net to get rid of the line. And so you take a bunch of images, and then your output, you manually remove the line, using Photoshop or whatever it is. You manually remove the line, and then you train a CNN to convert the input to that output. All right, that would be, the output would just be a converted image. This is probably going to be like a GAN situation, right? An adversarial network based on one of the later episodes of Mr. Jeremy's class. And so it's outside the scope of this specific application that we're trying to do. But I would say that's a possibility. If you can create a network that tells the difference between, so it tries to guess which of these images has the line in it, then that would allow you to create, a network that removes the line. Once you've removed the line, then it's simply a question of either taking the same approach that Mr. Adam introduced us to. It could work. I think it could. To probably take a blob or a chunk, even if they're all one big chunk, and separate it 5 equal pieces, since it's always 5 characters. Or you could try and get, really creative and try and find blobs that have a certain center of mass, like the equivalent of a center of mass, right? For each individual blob. I'm not sure how that would work. I don't want to get too philosophical into this, but yeah, let's go ahead and see what this bad boy is doing. This solving CAPTCHAs. So again, we're looking at this data set. All right, so he's got a data set. Let's take a look at that data set. This is the second part in a series of posts about automatically solving CAPTCHAs with deep learning. The first part can be found here. All right, cool. This is our CAPTCHA, blah, blah. Cool. All right. They can contain numbers. Images have noise applied to them. All right, it's cool. That's cool. That's cool. Cool. And so fast AI. Oh, cool. He's doing fast AI too. Decided to try a project on my own. Nice, nice, nice. CNNs, all right. All right, so he's already got the training images. That's nice. Multi-label classification allows us to tell which characters are present in the CAPTCHA. Okay, so I'm not sure if he's actually going to solve this issue or not, but let's read on. All right, blah, blah, blah. Four, 5C, 5D. Oh, he didn't segregate. He didn't even try to segregate it. All right, so he's doing the same thing that we had done before. It's like, unfreeze and then do training with smaller error rates, and then gradually increasing towards the later layers. Blah, blah, blah. Then you pick a learning rate, right? Yep. Mm-hmm. Cool, yeah. Alright, the next step is to actually add information about the position of the characters. I like that. Alright, so this bad boy is going the whole way, Mr. Oliver. Alright, let's keep going. So he doesn't try, we know that he's not trying to segregate the characters. That's very nice. Cool. Standard classification task. The input is the image of the CAPTCHA. The output is a single class corresponding to the first character. Solving the first character on a CAPTCHA. Alright, first character. Alright, yeah. Blog and first character. 95% accurate, that's pretty cool. MNN, yeah. M and is that N? Yeah, okay, that makes sense. It's getting confused there. Class activation maps. So-called CAMs can be used to visualize which part of the input image was important in the classification process. It's basically a rudimentary way to have the model explain its decision. Alright, cool. That's interesting. As you can see, the model seems to be doing what it's supposed to do. Righty. Yeah. 5 characters, 5 classifiers. Whoa, okay, nice. He doesn't even try to separate. I love this. Doesn't even try to separate it. You know, you sitting thinking, oh, how am I going to separate this? You know, it's going to impact accuracy, blah, blah. Damn, this guy just went after the whole thing and just worked. Alright. Final accurate. So, did you need to do anything to do this CAMS thing? No, man. Like, that's actually he's just visualizing the output. He's not doing anything. For I in range, data from position I. Okay, so he's getting the data, train a new learner, run the learner, fit one cycle, slice, fit again, and append your learn. Now you have a bunch of learners. That's it. Whoa. Okay, this is amazing. Wow. I am impressed. Exactly right, 95% of the time. Whoa, okay. Alright, so this basically tells you, basic math, right? Basic math tells you that you want to, so the likelihood of it not coming out correctly in one shot is 0.05, right? 0.05, that's the likelihood. The likelihood of it not getting it right twice is 0.025. 3 times 0.000125. Well, okay, so just run it on the same, no, not same image, it'll be different image, right? Run it 3 or 4 times. Two times is more than enough. 2 or 3 times, 3 times max, and you set. Like, you don't even have to go back and double check. You can be almost certain that the CAPTCHA is 100% accurate. Yeah, this has me thinking that it's actually, look at those digits. He didn't even give a crap, right? He didn't even try to segregate the characters. He just went right with it. I was here thinking, all right, how are you going to get rid of the line? You know, you got to train a model to do that. No, it doesn't care. Let it figure it out. This is amazing. This is awesome. All right, I think this is an approach that can actually work. You know, maybe just go straight to that last part. Alright, not try to do so. Alright, so basically skip thresholding, skip background, and skip This is interesting. Alright? I want to see what happens if you skip steps 2 to 4. Alright? Skip it entirely. Don't try to teach it. Don't try to micromanage. That's how I see it. You're trying to micromanage when you try to do the thresholding, getting rid of the background, segregating the characters. That's what you would do if you were like from a real programming background, right? Oh, I just want to program, like I want accuracy, of course, like that's how you're gonna think. But, man, let it figure out what's important and what isn't. You get the data, that's your job.